Hello and welcome back. In this course we'll talk about the first type of filter, and that is RC low pass filter. To create a passive low pass filter, we need to combine a resistive element with a reactive element. In other words, we need a circuit that consists of a resistor and either a capacitor or an inductor. In theory, the resistor-inductor low-pass topology is equivalent in terms of filtering ability to the resistor-capacitor low-pass topology. In practice though, the resistor-capacitor version is much more common, and consequently, the rest of the course will focus on the RC low-pass filter. As you can see in this diagram, an RC low-pass response is created by placing a resistor in series with the signal path and the capacitor in parallel with the load. In this diagram, the load is a single component, but in real circuit it might be something much more complicated, such as an analog to digital converter, an amplifier, or the input stage of the oscilloscope that you are using to measure the response of the filter. We can intuitively analyze the filtering action of the RC low-pass topology if we recognize that the resistor and the capacitor form a frequency-dependent voltage divider. When the frequency of the input signal is low, the impedance of the capacitor is high relative to the impedance of the resistor. As a result, most of the input voltage is dropped across the capacitor and across the load, which is in parallel with the capacitor. When the input frequency is high, the impedance of the capacitor is low relative to the impedance of the resistor, which means that more voltage is dropped across the resistor and less is transferred to the load. As a result, low frequencies are passed and high frequencies are blocked. This qualitative explanation of RC low-pass functionality is an important first step, but it isn't very helpful when we need to actually design a circuit, because the terms high frequency and low frequency are extremely vague. Engineers need to create circuits that pass and block specific frequencies. For example, the audio system described in the previous course, we wanted to preserve a 5 kHz signal and suppress a 500 kHz signal. This means that we need a filter that transitions from passing to blocking somewhere between 5 kHz and 500 kHz, isn't it? Alright, here we are. This is a low-pass filter consisting of a resistor and a capacitor. The input signal is generated from a signal generator, which outputs a sinusoidal signal starting from 20 Hz up to 1 kHz. Since this is a low-pass filter, you can notice that as the input frequency rises, the output signal's amplitude starts to decrease. Low-frequency signals can pass through the circuit without amplitude attenuation.